It's a lesson on Lewis structures for covalent molecules. In a covalent molecule, the valence electrons are shared between two atoms. When they're sharing, they share pairs. They're really sharing orbitals of the electrons. There are two types of pairs of electrons. There are bonding pairs. A bonding pair is what connects the atoms together. And then you have a lone pair. And a lone pair is a pair of electrons not connected. Set atom. One of the difficult thing for people to do is to arrange the atoms. Several general categories or ideas would help. The first atom in a small molecule, 5 atoms or less. So if you have 5 atoms or less, the first atom will be the center of the molecule, and then you build out from there. Almost all the time, carbon is in the center, or if it is an element in the compound I underline, the underline will be in the center. So that's how you can tell if something's in the center. If you have a halogen, fluorine, chlorine, bromine, iodine, or hydrogen, these are always for you on the outside. They don't go on the inside because they're dead ends. They usually will bond with only one atom. Now, halogens, there are some exceptions, but we don't cover that in this course. In the book, if you have a big string of things, they're trying to tell you how to put them together. You have C5OH, C2H5OH. You ignore the hydrogens and put 2 C's together and an O. So that's another way. Ignore the hydrogens and the chlorines, and then you put those together in the order that you see them from left to right. Single bonds. Have one pair of electrons shared between the two atoms. Example would be I2. Iodine, there's 2 of them, so you write down an I and an I, and do Lewis dot diagram. Iodine has 7 valence electrons, so you always put a single towards the other atom and fill it in. If you have a double bond, or if you have more than 4, the double bond, the lone pair, will be away from it. So if you have more than 4, it's going to be like that. So this is 7, so that's 1, 2, 3, 4, 5, 6, 7. So that iodine atom brings 7 valence electrons. This iodine atom, I'm going to use a different symbol so you can see where they're coming from. You put the odd one here, and it's just going to be the mirror image. It's probably usually the best way to go in about it. So there's 2 on top and 2 on the side. You connect. Then you count the electrons. On the left-hand one, there's 1, 2, 3, 4, 5, 6, 7, 8. And that's what you're looking for, 8 valence electrons. 8 is great. 1, 2, 3, 4, 5, 6, 7, 8. 8 is great again. So that is the molecule. The connecting pair here is the lone pair. Or sorry, that's the bonding pair because it connects them. And any of these on the outside are the lone pairs. So this would have 1 bonding pair and 6 lone pairs. 3 on the first iodine, 3 on the second iodine. Then you have double bonds. Double bonds don't have 1, they have 2 pair of electrons that are shared. So that's 4 electrons total. Example of that would be oxygen, O2. So you have 2 O's, put them down. You put a singleton towards the other one. And you have more, oxygen has 6 valence electrons, which is more than 4, so that doubled up lone pair will always be away from it. 1, 2, 3, 4, 5, 6. Mirror image over here. 1, 2, 3, 4, 5, 6. Join them up. Now on this side, there's only 7 electrons, and on this side there's 7 electrons. So on the left hand side oxygen there's 7, right hand side oxygen there's 7. It's not happy because it's not 8. So these 2 loners come join the party inside. So you got to erase them and move them inside. The bonding pairs are always on the inside. Do not do a shortcut and try to connect the 2 dots below it. And that's not going to be acceptable. In this case, there's going to be 2 bonding pairs and 4 shared pairs. And then we have triple bonds, which is the highest you can go. You cannot have 4. Where you have 3 pair of electrons that are shared between 2 atoms. Example would be nitrogen, N2. So you have N and N. N has 5 valence electrons. That's more than 4. So the connecting atom, or electron, bonding electron would be there. Lone pair on that side. So there's 5. Mirror image. Connect them. Now you only have 6 pairs of electrons, 6 electrons on each side. So it's not happy, but there are not 1 but 2 sets of loners. There's 2 single dots, so you erase those and bring them inside for the party. And these loners get together and they come to the party. Now there are 8 electrons on both sides. There are 3 bonding pairs and 2 lone pairs in this case. A couple bond length, strength, bond strength and length. Strength, if you have more bonds, it's stronger because you don't. You have to use energy to break a bond, and so in a triple bond, 3 in triple bond is stronger. That means a single bond is weaker. If you're talking about length of a bond, a triple bond, even though it has 6 electrons in there, is actually shorter because there's more negative electrons for the nuclei, positive nucleus, to grab onto. So it pulls it a little bit tighter. And again, that would make the single bonds longer. And the double bonds will fill in between somewhere. Now a couple examples. PH3, and I'm going to underline the P because that's the center atom. So you have P has 5, it doesn't matter where they go. H has 1 valence electron, so you got to face them towards each other so that they can bond. Connect the dots. Now the P has 8, 2, 4, 6, 8, but the hydrogen only has 2. That's okay because hydrogen's a small atom and it can only have a full outer shell with 2 electrons. So hydrogen's happy with 2. So my saying is 8 is great. 2 is 2 for hydrogen. So it's a neat little saying that I got. 8 is great, 2 is 2. And for you people in this course, that's going to work. That's all there is. Let's do H2CO. Put C in the middle. Carbon has 4 dots. 1, 2, 3, 4. 4 valence electrons, 4 dots. Oxygen has 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. There we go. That counts. Hydrogen. There's 2 hydrogens with 1 valence electron each. Now, the carbon and the oxygen are not happy because they only have 7 each, but again, notice there's lone guys here. So they get erased and moved inside. So that's a lesson on how you write covalent molecule, a little instruction for covalent molecules.